Good evening to everybody. Will not bother whether somebody will come or not. Can you see my slide, please?
Yes, sir, it's visible.
Okay. Till date, during the last, I think so, 15, and we had a class on 15, 16, and we heard about the biomedical waste rules as well as the other aspects relating to the treatment and pre-treatment and disposal options, and what are the disposal options for biomedical waste. And today we will hear. I'll take a class on burn and non-burn technologies for treatment and disposal of biomedical waste. Am I audible to you?
Yes, sir.
Okay. And in the last class also we heard the components of biomedical waste management. Not only the biomedical waste management, any waste management, the main components of waste management will be generally segregation at source. Wherever the waste is there, that has to be segregated in accordance with the respective rules, and thereby the proper collection and its safe storage. Thereafter, the waste has to be transported for further treatment and disposal. For the purpose of treatment and disposal, the treatment and disposal may be a on-site and off-site. These are the major components of biomedical waste management. Not only the biomedical waste management, in any waste management activities, segregation at source is very important. Collection and safe storage is very important. Transportation, safe transport is very important, and treatment and disposal are the main components of the biomedical waste management. Now, coming to the hierarchy in waste management, we also learned in the last class that the most preferable, the hierarchy in waste management is the prevention of waste generation is the most preferred option, whereas we have to adopt the various measures like reduce, reuse, recycle, recover. What are the waste? Even after adopting these 4 R's, reduce, reuse, recycle, and recover also, if any waste is there, which cannot be, no waste can be recycled or reused or recycled or reduced, then such waste has to be treated and disposed of in the environment in order to minimize effect on the environment and the public. Therefore, most preferred option in the waste management hierarchy is the prevention of waste generation, and the least preferred option in the waste management hierarchy is the disposal. Always remember these 2 words. These questions, you can expect these 2 questions definitely. Which is the most preferred option for waste management action in the hierarchy is prevention, and which is the least preferred option in waste management hierarchy is the disposal, is the least management hierarchy. Now, apart from that, we also learned various technologies for treatment and disposal of biomedical waste as per biomedical waste rules 2016 as amended are all yellow color waste, that is, we call it as highly infectious waste, will go for incineration or plasma pyrolysis. And third option is the deep burial. Where is the deep burial we allow? Anybody can say, please? Yeah, please kindly react to me, please. Otherwise,
in rural area, sir.
Yeah, in which area? In rural areas. What is the other way where the deep burial is permitted?
Where common waste management treating facility is not possible, there we are allowed.
Yes, what is said is correct, ma'am. Thank you very much for your kind response. The deep burial is allowed in a place where there is no access to common facilities, and also allowed in rural areas where there is no any common facility at all. We can therefore, the yellow color waste is generally treated by incineration, plasma pyrolysis, or disposed of by deep burial. Deep burial is allowed where there is no access to common facilities and in rural areas. And other waste like red red color waste means the plastic waste, or white color waste is like that is the waste shops, and glass and body implants can be disposed of by adopting methods, can be treated by adopting methods like autoclave, adclaving, dry sterilization, microwave, or combination of sterilization and shredding. Means either you can have autoclave followed by shredding. Shredding followed by autoclave cannot be there, but autoclave followed by shredding can be there for ensuring there is no proper treatment. For ensuring proper treatment of no reuse of waste is there, shredding is a must. after treatment of waste by autoclave or hydroclave or dry sterilization or chemical disinfection. How much percentage of chemical disinfection the sodium hypochlorite solution we have to use as a chemical disinfectant? Anybody can say?
1%.
1 to 2% of sodium hypochlorite solution. What should be the percentage of chlorine in that? How much percentage of chlorine should be?
1%.
No. In hypochlorite solution of concentration 1 to 2%, what should be the chlorine content in that? You should have chlorine content of 30%. You remember all this.
Okay.
Therefore, in 1 to 2% of sodium hypochlorite solution, you have to have 30% of chlorine content.
Okay.
And using this solution, you can treat the anyways for how many duration? How much duration? Not less than how much minutes? How many minutes? See, chemical disinfection using 1 to 2% sodium hypochlorite for how much time the sterilization duration is? For the time of sterilization duration in case of chemical using 1 to 2% sodium hypochlorite solution containing 30% chlorine. What should be the sterilization duration?
Is it 15 to 20 minutes?
Yeah, not less than 20 minutes. Okay, not less than 20 minutes.
Okay.
Minimum should be 20 minutes. Okay.
Okay.
That's one thing. Okay, then after knowing this, after saying this, then we can also use methods like encapsulation and sanitary landfill that we have seen in my last class. And the treated plastic waste can be disposed of by encapsulation or sanitary landfill, or treated plastics can be used for energy recovery of diesel or fuel oil, or for road making purposes we can use. Now, these are the only technologies approved under the technologies for treatment of biomedical waste and disposal options stipulated under the biomedical waste rules. Now, other than these technologies or disposal options, if somebody wants to come out with any other treatment technologies or disposal options, then that proponent has to submit the proposal to the Ministry of Food and Forest. Thereafter, the Ministry of Food and Forest will examine the proposal received from the proponent, and thereby they will notify they will examine, then they will conduct trial runs afterwards. They will notify the standard operating procedure for all this new technology. Once it is notified, only that proposal on new technology can be adopted for treatment and disposal of biomedical. Otherwise, none of the hospitals or COMFEST are allowed to adopt any new technologies other than mentioned under these rules. This is what you have heard in the last week. I just want to recollect, that's why I call you. Now, coming to the topic given to me today. Today, what you are going to hear is a pure science. It is a science actually, but I don't think so you require to go into such a deep knowledge. I hope so. That is not okay because you're not an operator. All of you are the students, but you should know what is the technology. So what should be the minimum requirement of the technology you should know. And that way only I will cover up. And the technology which are required for the hospitals, healthcare staff, then such technology we have already discussed. Still, once again, we will have once again some sort of reminder. Now, any waste which cannot be recycled or reused or sent for landfill, any waste which cannot be reused or recycled or sent for landfill, then that waste can be treated by using two technologies. What are they? One is burnt technologies and other one is the non-burnt technologies. In case of burnt technologies, there are two technologies with us. Can you please tell anybody can guess, please?
Incineration and plasma pyrolysis.
Yeah, there are two technologies, incineration and the plasma pyrolysis. Okay. Then in case of non-burnt technologies, we have thermal processes using heat as a mode of treatment, whereas the chemical processes where the chemical use as a mode of treatment. What is the chemical process? One type of example, can you please say? Anybody can say? One type of chemical process, please. Anybody can say?
Using hypochlorite solution.
Yeah, that
Sodium
is
hypochlorite.
what is the technology for? What you call it as chemical disinfection. It is called chemical. So It is called chemical processes. We can use this technology, that is the chemical infection. And other processes are there only mechanical, means we go for shredding, mechanical equipment use, and we go for shredding and all. This is one of the technology. And biological processes. There are 4 types of non-burn technologies. You always remember this. What are the burn technologies? One is incineration, and the other one is the plasma pyrolysis. Or in case of non-burn technology, there are 4 types of the technologies. One is thermal processes, chemical processes, mechanical processes, and biological processes. In case of thermal process, we have got the technology like microwave. Is one of the technology, and we have got one technology called hydroclave. Similarly, we have got one more technology that we call it as autoclave. And autoclave and hydroclave are one of the same, but here the technology is same, the mode of treatment is same, using steam, whereas microwave, where we use microwave energy as mode of treatment. Any questions, please? Any questions? If no questions, how the waste is going to be incinerated? What are the stages of operation of the incinerator? In case of before incineration, waste has to be collected, segregated waste has to be collected, stored properly, and waste has to be seen that which there is a proper mix of having the adequate calorific value of the waste. Only such waste can be incinerated easily. Then we have to have the proper combustion chambers of the incinerator. There are 2 types of chambers. One is primary and secondary chambers, where in primary chamber waste is discharged, or the waste is charged into the primary chamber, where the waste will undergo heat treatment, where you use fuel and air as the required the requisites for having proper burning in the primary chamber, where the waste is going to be converted from into carbon monoxide. Carbon in the presence of oxygen is going to be converted into carbon monoxide, and in secondary chamber, in presence of the adequate air and the fuel, the carbon monoxide is converted into carbon dioxide. Therefore, that is the complete combustion. Combustion means carbon in presence of oxygen should be converted into carbon dioxide. Then it is called as proper combustion. Then in the process also, you can try for heat recovery. You can try to recover heat. Generally, heat recovery is not practiced in any of the most of the common facilities in the country. Only somewhere I've seen one common biochemical treatment facility somewhere in Srinagar. I've seen there they were recovering the steam. They're trying to generate steam in order to maintain desired temperature, because in Srinagar during winter time they will have a very cold. Therefore, in order to maintain adequate temperature in the primary chamber or secondary chamber, they will try to recirculate the steam as a part of by replacing the air. All of the air they will send steam also, so that they will have adequate temperature. In any of the common facilities in the country, no one is going for heat recovery. And subsequently, after burning of waste, the flue gas is generated. Therefore, we have to have proper cleaning system, and followed by in the process of combustion of the waste, burning of waste under controlled conditions, we are generating the ash. Therefore, ash generated has to be treated and disposed of. The method I will show you, it may somewhat may be difficult, but I will show you the diagrams so that you will understand easily. Now, burn technologies. In case of incineration, there is open burning technologies, incineration, plasma. Now, this open burning technology is no more permitted and no more exist. Open burning technology is obsolete and not a technology approved under the rules. Therefore, this particular technology is not permitted. Therefore, burn technology is now only incineration and plasma pyrolysis. Open burning is obsolete technology, and nobody is permitted to adopt this open burning technology. And the principles we are going to study in the principles of incineration. What are the harmful effects of incineration, advantages and disadvantages of incineration, waste characteristics of incineration, and air pollution control devices. Let us see what are they. I already told open burning technology is not a permitted technology, where the open burning of waste causes a lot of impact on the environment, because it is not a controlled combustion. Because of improper combustion, we may discharge hazardous, the air pollutants, harmful gases such as oxides of sulfur, oxides of nitrogen, carbon dioxide. Apart from this, we will be generating the particulate matter as well as the dioxin fuels. This is the element which is going to cause the carcinogenic effect on the environment If any waste is burnt improperly, under controlled condition is not there, that is not, the waste is going to cause various gases, oxides of nitrogen, oxides of sulfur, carbon dioxide, and toxic emissions like dioxin, furangs will be emitted because of the available presence of chlorinated compounds in that waste as a part of the waste. Therefore, open burning of waste is not at all permitted and is an obsolete method and is not at all allowed in case of, because of its impact in the environment. Now, coming to incineration. Incineration is nothing but a combustion or degradation of total organics in presence of excess air at high temperature, and in the process of inversion, the incineration, it converts organic and commercial waste into inorganic combustion matter, signifying reduction of waste volume and weight. Therefore, by incineration is nothing but the degradation of organics in presence of excess air into and converting that organics into harmless compounds or harmless waste or ash. And also, apart from this, one more important advantage of incineration is significant reduction of waste can be minimized, waste can be reduced, waste volume can be reduced, and also weight of the waste can be reduced. Because of after treatment of waste, we are going to get only the ash, and whatever the emissions are generated, we are going to control through air pollution control devices, and we are going to generate some sort of liquid waste, and liquid waste is treated. In the process of treatment of liquid waste, we are going to generate some sort of effluent treatment plant sludge. We call it as ETP sludge. That is also hazardous in nature. Therefore, that waste also has to be disposed of through landfills. Now, instead of waste materials, as you all know, the waste materials is nothing but the carbon. It is a carbon content in presence of the oxygen. Waste we have to convert and destroy this waste completely by oxygen production. And in the process, we are going to generate gases such as carbon dioxide, water, and nitrogen, and some other gases such as oxides of sulfur, nitrogen, acids, and other toxic gases are generated in the process of incineration of the waste. And also, we are going to generate some sort of ash, already told you, and heat is also generated. Generally, heat is not going to be recovered in the COM facilities, especially in the biometric waste facilities, and that is disposed of. That is actually ignored. Now, coming to this is what you have to understand easily. I'm sorry. If you see the combustion process, this is the combustion process. What I want to say is that, so that you can understand easily, try to understand, this is the combustion chamber, which contains primary chamber and secondary chamber. There should be two parts in this. One is primary chamber and secondary chamber. Here we are going to give the input or waste. We are going to charge waste into primary chamber. Apart from that, fuel as well as the air is circulated in the primary chamber. Here in the process of combustion, we are converting the carbon in presence of oxygen. It is a simple equation, not required to worry about the complex of the nature. It is a very simple equation you have to understand. Combustion is nothing but there should be the carbon in presence of oxygen has to be converted into carbon dioxide. In the process, the heat is generated. In the incinerator process, is heat is generated is called as exothermic process. When heat is generated from any combustion, it is called exothermic process. Exothermic process. Therefore, waste is nothing but carbon content in presence of oxygen. You are converting this waste. Kindly remember this equation. You can expect this. Therefore, carbon, it is a waste in the presence of oxygen and the fuel. Waste is converted, the burnt, converted into CO2. Plus, apart from that, the heat is generated in the process of incineration. Therefore, whatever the waste, generally, what the waste is generated in the primary chamber is generally is a complete combustion. If it is a complete combustion, carbon in presence of oxygen will generate carbon dioxide and heat is generated. And water which is present there will be going to convert the hydrogen which is there will be converted into water. Therefore, in combustion process, we are going to convert waste into CO2 as a gases and other gases, and also moisture as well as the heat. There are T process. The process of waste is also going to be converted into the ash. That is the ash content. Whereas the emission process, we are going to convert the waste into CO2. Apart from that, there will be as gases are generated, and whatever the hydrogen and oxygen in presence of oxygen is converted into moisture. Therefore, the combustion process, we are converting the waste into CO2, and in the process, heat is generated and also moisture is generated. That is becomes a part of emissions. Now, therefore, in the process of this is what I want to say, that this is the component process where waste is charged. Here we are feeding fuel apart from air, adequate air into the primary chamber. Therefore, waste is converted into here. In the first stage, always carbon in presence of oxygen converts into carbon monoxide, which is highly toxic in nature. And in the secondary chamber, this secondary chamber, when it goes into the secondary chamber, CO in presence of oxygen is completely converted into CO2, and gases will be emitted into the atmosphere, whereas the waste converted into ash is taken from the bottom. Therefore, for proper combustion, there should be 3 T's. We call it 3 T's are required. One is temperature, residence time, and turbulence. These are essential for proper combustion. What are the 3 T's called? One is called as the temperature and the residence time and turbulence. These are the 3 T's are required for combustion of any waste into harmless compounds. Therefore, combustion chamber with a burner will be provided, waste feeding mechanism will be there, air supply system will be there, and flue gas extraction and cleaning system will be provided here. This is after flue gases. What are the gas are generated? It will pass through the air pollution control system. I will show you the example. And in the process of treatment of these flue gases, wastewater is generated, and that is treated further, and the ash is generated, and the waste e-waste sludge is generated. Here, from bottom of this, from bottom of a portion of the inside portion, we will generate ash. This is collected and disposed as the harmless compound. Therefore, first, in the primary chamber, waste is converted into carbon monoxide in presence of water, in presence of oxygen, and carbon monoxide is the completely combusted in the secondary chamber in presence of the fuel and air. Then the CO2 under the gas are generated that will go through that. We call it as a flue gas, apart from toxic gas. Therefore, various gases will generate in the process of combustion is hydrochloric acid, the chlorine dioxide will also be generated, and nitrogen dioxide also will generate. Apart from this, if APCD is not proper, then you are going to generate the very what you call highly toxic gases called as dioxin fuels. Now here you see this is what? The combustion chamber, double chamber, primary and secondary, and air the air and fuel is supplied apart from the waste. Here the waste is converted to harmless compound. What are the flue gases generated is pass through the flue gas cleaning system, where after cleaning the gases will be emitted into the atmosphere. Some type of from the air pollution control systems we get some ashes is collected, and also some wastewater generated from these gases scrubbed through this liquid waste is generated. That liquid waste is also treated through ETP. In the process of treatment of wastewater, we get water. That water treated water is recycled into the system. Generally, it is recycled, not discharged. And from wastewater ETP, we get sludge. That sludge is generally treated and disposed of. This is ash from bottom of this incinerator chamber. Will get ashes. That is the harmless compound that you can dispose of through the common facilities or through treatment or you can dispose of through secure landfilling or sanitary landfilling. This is what I told you, the typical example of the incineration. There is the primary chamber. Here the waste is feeded. We got the feeding mechanism, and air is supplied and fuel is supplied here. And here in the first stage, waste is converted into carbon monoxide that passes through this secondary chamber, where this is the burner. You see, this is the burner. This is the burner, and air supply is given, where carbon monoxide in presence of fuel and oxygen converted into carbon monoxide that will pass through. This is the systems we call it as air pollution control devices. Here there is a venturi followed by the absorption. Wet scrubbing systems are there. Finally, demist, the mist collection is there. Finally, this is sent through a stack of height 30 meters. You remember, stack of height, minimum stack of height for incineration should be 30 meters. Now, pyrolysis is nothing but the incineration, where here waste where here you are not going to give the huge quantum of oxygen. Here you are going to give less quantum of oxygen. Therefore, in presence of less quantum of oxygen, you are going to use the plasma at the heat of mode, and using the plasma, you are going to generate the temperature higher than 5000 degrees centigrade, where using the plasma. Therefore, torch. Therefore, using the adoption of the electricity, and in presence of oxygen, and the waste and starved condition. We call it as starved condition. We are not going to give adequate quantum of oxygen. In starved oxygen condition, the waste is going to be converted into gases like syngas. We call it as gases like methane, carbon monoxide, and hydrogen. And this hydrogen is going to act as the fuel for them. Therefore, in secondary chamber, no fuel is required. That will be burnt automatically. The higher temperature is maintained and waste is generated. Therefore, coming to the plasma pyrolysis concerned, yeah, this is the plasma torch where high temperature is maintained using the plasma torch, and high temperature maintained. Primary chamber, all the gases are going to be converted into syngases like carbon monoxide and the methane, and the way I told, this methane, carbon monoxide, and hydrogen. Here, these gases are in presence of oxygen, converted into flue gases. The flue gases are going to be cleaned further. Then, after cleaning, the gases, that clean gases will be emitted into the atmosphere, whereas as generated is collected and that is treated and disposed. Here, from cleaning process, here ash is also collected, that will be disposed through landfill, and in process of cleaning of gases, toxic gases, we use wet systems, means not we use water or the alkaline solution for cleaning of these gases to neutralize the acid gases. Therefore, in the process, liquid waste is generated that will go for treatment of ETP. After treatment, wastewater is recycled back into the air pollution control system. This is the incineration, where incineration is nothing but conversion of organic waste into harmless compounds under presence of oxygen and adequate oxygen and fuel. Whereas in case of the pyrolysis is nothing but the process of thermal dissection of organic waste at high temperature and in oxygen starved condition. Therefore, where here in case of pyrolysis, we are not going to give adequate oxygen, and we maintain high temperature using plasma torch. And in the high temperature, the waste is going to be converted into methane, carbon monoxide, and hydrogen. Hydrogen is a high calorific value, the pollutant that can be easily burnt in secondary chamber, so that we can convert the waste safely using the pyrolysis process. Generally, the highly toxic waste is treated using the pyrolysis process. Difference between the different operating conditions of incinerator causes toxic emissions. I told you toxic emissions are emitted into the atmosphere. Various gases like the dicynfurans. In case if you are not maintaining adequate residence time, or if the burning is not proper, you are going to generate toxic gases. If your cleaning system is also not properly working, in such a case also the toxic gases may be, there is a possibility that there will be toxic gases may be generated and may be emitted into the atmosphere. Therefore, you can expect, depending upon the type of waste is concerned, we may expect different types of waste. For example, any waste is mercury bearing waste mixed up with biomedical waste. If you treat such waste, then we can expect the mercury emissions into the atmosphere through incineration process. Generally, if you see, any medicine may contain generally we may contain zinc, the iron, manganese, nickel, and some heavy metal constituents also in traces. When they go for the incineration, all these metals or heavy metals also may go into atmosphere. Therefore, without air pollution devices, you cannot. Therefore, toxic substance produced during incineration, depending on the type of waste is concerned, you may generate dicynfurans. You please kindly remember these words. These are very important for your exam point of view. Mercury also may release emissions of other gases like oxides of nitrogen, oxides of sulfur, and carbon monoxide and CO2 also will be generated, and ash is generated in the process of the incineration. And this you have to remember. And depending upon the type of pollutants or emission control systems, you are going to generate different types of pollutants like dicynfurans and other the acid gases like hydrochloric acid, sulfuric acid, sulfur dioxide, nitrogen dioxide, hydrogen fluoride, hydrogen, and we are going to generate organic compounds also depending on the type of waste available in the waste, along with the biomedical waste. If any waste is containing, heavy metals containing waste is there as a part of waste, like arsenic, mercury, chromium, lead, and these also become a part of air emissions into the atmosphere. Therefore, apart from this, we are going to generate fly ash. Fly ash is going to be a harmless compound. This you can dispose of in the landfill. Therefore, these are the problems associated with the incineration. If it is not properly adopted, then it is going to cause emissions like the air. It is going to cause air emissions, and it is going to cause global warming of the climate change. Also, it may cause the acid rains. It also may cause impact on the health impacts due to the particulates, and it may also cause the impact due to the toxic gases may cause the impact on the environment, apart from the solids like particulates through the emissions. If particles, these all these things you can expect only when air pollution control devices are not properly operated. If you are adapting the proper air pollution control systems, if you are operating the proper air pollution control system, definitely all these particulates, acid gases, and heavy metals and the toxic gases can be minimized definitely, and we can impact on the environment can be minimized definitely, provided if you ensure the air pollution devices are operated properly. Now, what are the effect of particulate matters? It is going to cause respiratory death in infants under 1 year, affects rate of lung function development, and also causes aggravates asthma, and causes this particulate matter causes problem like respiratory symptoms such as cough and bronchitis in children. Therefore, apart from these are the problems associated with the particulate matter emissions from because of the incineration process, may cause also increasing deaths from cardiovascular, respiratory diseases, and lung cancer is causing effects. PM10 it also causes respiratory morbidity as indicated by hospital admissions or respiratory illness in WHO. Therefore, you might be knowing nowadays about pollution in North India, especially during the winter, and Delhi or in Mumbai or any other places because of the particulate matter and other gases are there because of the combustion, improper combustion. The open burning of wastes will happen during the winter. People will take used tire and they will burn. They take municipal solid waste containing plastic waste or polyvinyl chloride plastic waste, they will burn. All this opening burning causes a lot of emissions in the environment. Under favorable conditions, the pollutants will not disperse because of the density of the air is high. Therefore, pollutants will be they suppress just above the ground level. That causes impact on the environment, definitely for the public, definitely. These are the impact of particulates is concerned, cardiovascular, asthma causes, and lung related the problems, respiratory problems will be there, and such as like cough and bronchitis will be there, problems will be there. And apart from this, the toxic metals are there, this toxic accumulate in the body over time. If mercury is there, mercury will accumulate in the body, definitely. Therefore, this accumulate in the body, they may cause problem to the problems. Large number of toxins emitted by incinerators can cause damage to the immune system and dangerous to the urban child because many of these toxins are actually transferred to the photos across the mothers, like mercury. If mercury emissions are there, that may become a part of the child who is about to take birth also. Therefore, if it is mercury, you might have heard Minamata Convention, Minamata problems. In Japan, there was a problem because of the mercury emissions at a place called Minamata. And impact of toxic gases emitted by the incinerator is acidic in nature. They cause health effects, affect the respiratory and cardiovascular system, and also causes skin, eye, and lungs problems. Side effects such as cough, nausea, and vomiting will be there. Therefore, these are the problems due to the particulates. These are the problems due to the heavy metals present in the because of the incineration waste containing heavy metals, and because of improper the incineration of the waste through the incineration process, it may emit toxic gases like acid gases, and these toxic gases may cause problems like respiratory and cardiovascular system problems, skin, eyes, and lungs. Also, side effects such as cough, nausea, and vomiting may cause. These are the problems due to the incineration. What should be the calorific value of the waste? So, when you are treating the waste by incineration, there should be minimum waste characteristics. Waste calorific value of waste should be at least about 2000 kilocalories per kg. Please kindly remember this. Kindly remember this particular value. You have to remember this. You can expect this. One of the question. And the calorie value of the waste should be about 2000 kilocalories per kg. And also the waste material should be able to combustion material should be above 60%, and remaining material should be less than 40%. And the calorie value should be at least 60% of the 2000 kilocalories per kg should be there, and the combustion material should be above 60%, and a non-combustion material should be less than the 40%, including moisture. This typographical error here, this should be 5%, not 20% here. Non-combustion material should be 10%, and remaining moisture content should be 30% actually. Waste which cannot be incinerated are the pressure gas containers. If you dispose of these pressure gas containers, that may burst inside it may create a blast in the primary chamber. Therefore, Pressurized gas containers should not be incinerated. Large amount of reactive chemical waste should not be incinerated. Silver salts and photographic or radioactive waste. Radioactive waste cannot be incinerated at all. It's going to cause the problem to the area. Halogenated materials such as polyvinyl chloride plastics should not be incinerated. Waste containing mercury, cadmium, and other heavy metals should not be incinerated. Include example like mercury thermometers, use batteries and lead-lined wooden panels. Radioactive materials also should not be incinerated. All pharmaceutical waste has to be disposed of only at higher temperature, having temperature more than 1020 degrees. Now, what are the air pollution control systems that they will adopt are generally there will be, we call it as the the dye systems. Therefore, these are the fabric filters. We call it as electrostatic precipitators. We call it as the wet systems, where we also can use removal of particulates like, therefore, you can use fabric filters or electrostatic precipitators. You can remove particulates. You also can use the cyclones. Whereas in case of the wet systems, we can use the water as a sprinkler. You can go, whereas the gases can be made to flow through this sprinkler system, so that the while the water is falling from top, while while I just want to open my my photo. See, when you are sending any gases from bottom, when it is moving to upward direction, whereas you are sprinkling from bottom, these water droplets will impinge with the particulates. In the process, they remove the particulates along with the water droplets. Therefore, this water, the system here, we call it as the absorption. This method we call it as absorption, where the gases are sent through in upward direction, whereas the water is sprinkled from the bottom on top. The water droplets will impinge with the particulates and they remove, and this will be brought to the bottom of particulates will be brought to the bottom. Now, apart from the water, we can also use the alkaline solution. This alkaline solution will neutralize with the acid gases which are coming from outward direction. They impact and they neutralize the acid gases. Therefore, the gases free from acids will be emitted into the atmosphere thereafter, or they will go for further treatment. This is also one of the method I told you. This is one of the dry method. It is a cyclone where the flow is made to circulate such a way that all the particulates are going to fall by means of gravity. Apart from this, we call it this is the best method adapted to the common facilities, where you can here remove all sort of gaseous emissions. Like we can use wet systems here. The wet system where the acids or alkaline solutions are used in order to neutralize the lime solution. Or see, if you use fresh water along with the acid gases, you are going to generate the acid waste water you will generate from the air pollution system. Suppose as a solution, here you are going to neutralize, and in the process of neutralization, you are going to generate some sludge only, not all. 1 minute, please. Sorry, excuse me. Now, can you see my slide, please?
Yes, sir.
Yeah, here, in order to clean the gases like hydrochloric acid or hydrogen fluoride or sulfur dioxide or mercury, etc., you can use the systems like Venturi. This system is called Venturi, where we use alkaline solution. When you use alkaline solution, they neutralize the acid gases. When you use fresh water along the absorbing agent, this will neutralize it will take the acid gases from the gases and acid is generated. And if you use the lime solution, alkaline solution or lime solution, you can use lime water also, lime injection also, apart from caustic soda solution. You can use lime also. When you use lime soda, lime injection, then we are going to generate a lot of sludges. When you use caustic soda, you are not going to generate a lot of sludges. That's the only difference here. Therefore, these are the wet systems where we can clean all the the gases emitting from the atmosphere. Here, this is the method we control the NOx, the removal of NOx emissions into the atmosphere, we use low cost NOx burners. Therefore, these NOx burners cause emissions of NOxins, the oxides of oxygen into the atmosphere very less. And also, you can adopt other methods. And reduction of oxygen emissions and PCDs. There are methods available. Are primary measures are there. Limitations of the de novo system means you have to reduce the temperature. See, in temperature, if you see the temperature to be maintained in the incineration, in the primary chamber, you have to maintain. Please remember this value, please. Please kindly remember this value, what I am saying. In primary chamber, you have to maintain a temperature of 800 degrees centigrade. In the primary chamber, waste is going to be converted into carbon monoxide. Okay, this carbon monoxide will go to secondary chamber, where this waste is going to be burned in presence of the adequate atmosphere, air and fuel. And this carbon monoxide is going to be converted into CO2. Here, in secondary chamber, you have to maintain a temperature of minimum 1050 plus or minus 50. Means 1050, 1000 to 1100 degrees centigrade, you have to maintain temperature so that you can restrict all the toxic gases in the secondary chamber. Then the gases will go for further treatment through air pollution control system. Therefore, in primary chamber, you have to maintain a temperature of 800. Secondary chamber, you have to maintain a temperature of 1000 plus 1050 plus or minus 50, means 1000 to 11 degrees centigrade you have to maintain. And residence time should be minimum of 2 seconds. You have to maintain residence time in the incineration chambers. Then only you can expect that waste is converted into harmless compounds. Otherwise, the gases, toxic gases may be there that may cause the impact on the environment. This we have seen how the chambers, secondary chamber and secondary chamber, you are converting, waste is going to be converted, and afterwards the flue gas system, how these systems are going to remove these the air pollutions, gases. Now, what is the air pollution? The incineration is nothing but burning mixture, where we have to adopt three T's, what we call as turbulence, reaction time, and required oxygen must be there, so that you can ensure the waste is converted into harmless compound. The incident is nothing but a controlled the conversion of waste, organic waste, into harmless compounds under controlled conditions and under controlled air supply. Here there should be air supply should be there, adequate air supply should be given, and so that you can ensure that proper waste can be restricted. And what are the types of incinerators? There are 4 types of incinerators are there, and 5 types are there depending on the type. Small scale and low case incinerators are there, which is not at all permitted now. They are called as single chamber incinerator. Secondly, single chamber high temperature incinerators are there, but they are expensive and are less expensive, but and they may be having 2 chambers, but they are not having any the air pollution control system. Therefore, these also a single chamber incinerator. And there is a double chamber incinerators are there. Let us see, without seeing this in examples, you can't understand. This is a simple type of system. It is the small scale incinerator, but without any air pollution systems. Here, only chamber is only one chamber. It is not having any double chambers. Or maybe small scale incinerator may be there. Here, there may be a 2 chambers. Here, there may any controlled air supply or fuel, simply burning. It is like an open burning, but it is a controlled chamber. One chamber is there, but no pollution control system. Second variety may be there, where it may be having 2 chambers, primary chamber, secondary chamber, burners are there, air supply things are there, but no air pollution control system. Directly, gases which are coming from secondary chamber are committed into the atmosphere. Therefore, single chamber incinerators or double chamber incinerators without APCD are not presently allowed at all. And they say they are, because they are going to cause a lot of impact on the environment. This is what I am going to say. This is the primary chamber and this is secondary chamber. This is a double chamber incinerator, but not having any air. Therefore, waste is here is converted into carbon monoxide, whereas the gases will flow into the secondary chamber in presence of air and fuel. The carbon monoxide is converted into carbon dioxide, but directly these gases are emitted into the atmosphere without any cleaning system. No cleaning system, directly going. Therefore, single chamber or double chamber incinerator without APCD are not at all allowed as on date by the rules in the country. One minute, please. 1 minute, please. I'm sorry for the inconvenience. There is some official matter. Now this is what. Therefore, in the country, single chamber incinerator or double chamber incinerator without APCD are not allowed at all. Therefore, double chamber incinerator is a must. Here you can see here. Let me enlarge this particular slide. This is the primary chamber where the waste is charged, the burner where the fuel is supplied and the temperature is maintained and the air is also supplied. After conversion of waste into carbon monoxide, it will go into secondary chamber. After this conversion of waste into CO2, if it is proper combustion there, the carbon monoxide in the presence of oxygen and the fuel is going to be converted into CO2. The process of combustion, we are going to generate various gases. The gases are going to be cleaned properly here. Afterwards, after these gases are cleaned, all the gases are going to be, after cleaning, these waste are going to be emitted into the atmosphere through the stack of height 30 meters. Remember this. What should the minimum height of stack should be 30 meters. What should the minimum height of the stack for incinerators? Minimum height of stack should be 30 meters. Please kindly remember that word. What in case of the rotary, this is one type of incinerator double chamber where the waste can be incinerated 24 hours. Whereas this is the conventional method, whereas in place of primary chamber, there is a rotary will be there. Here the waste can be, it is like a rotary drum type, it will be in rotating form. The waste, the feeding system, waste is charged and waste is converted into carbon monoxide. This will go to secondary chamber. Then afterwards, waste will go for the pollution control system through APCD. Once the waste is completely controlled, gas are controlled, gases, clean gases will be emitted into the stack through stack of height the 30 meters. Now, whatever the liquid waste is generated from the air pollution control system that is treated, the treated water is recycled back into the air pollution system. This is one of the, this is what example. In case of incinerator, conventional system is primary chamber, secondary chamber. Here, in case of this also rotary kiln is also one type of the incinerator. Here, this is the primary chamber. It's not a box type, but it is a rotary. It is a rotating drum where waste is properly mixed and temperature and the residue time is maintained. By the time waste is charged here, by the time it goes, it will have a residue time of 2 seconds and all proper waste will be converted to carbon monoxide. This is secondary chamber. After this, waste will go for further treatment and disease. This is the rotary kiln. Rotary kiln is preferred for treatment of huge quantum of waste and we can operate for 24 hours when compared with the conventional the incinerator. Rotary kiln is preferred when the quantum of waste to be treated is high. Therefore, you can ensure complete destruction of the waste if you adopt the rotary kiln. Therefore, incinerators we have got different types. One is single chamber incinerator, double chamber incinerator, and a pyrolytic incinerator is there. Rotary kiln incinerator is there. Drum or in case of single chamber, no APCD is not at all preferred. In case of double chamber, without APCD, it is not at all allowed because it is going to cause a lot of impact on the environment. And the rotary kiln is most preferred when the quantum of waste is high and it is we can achieve desired quantum of efficiency. And drum type or engine incinerator, the conventional brick kiln incinerator is not allowed. And the incinerator with a double chamber with a proper air pollution system and a stack of height 30 meters is preferred. And the incinerator should have to comply to the requirement of standards as per Schedule 2. What is the standards? Combustion efficiency. Please kindly remember this word. Combustion efficiency at least you have to achieve is about 99%. How much you have to achieve is 99%. The combustion efficiency can be the calculated based on the carbon CO2 levels emissions in the through stack, and we will see that what is the combustion efficiency, and that should be always 99%. Primary chamber you have to maintain a temperature of 800. Secondary chamber you have to maintain a temperature of 1050 plus or minus 50. Always temperatures are preferred. ಏನಮ್ಮ ಯಾಕೆ ಬಂದರೆ ಸ್ವಲ್ಪ ವೇಟ್ ಮಾಡಿ ಕೂತ್ಕೊಳ್ಳಿ ಕೂತ್ಕೊಳ್ಳಿ ಈ ಕಡೆ ಬನ್ನಿ ಇಲ್ಲ ಬನ್ನಿ ಕ್ಲಾಸ್ ಕೇಳಿ ನೋ ಪ್ರಾಬ್ಲಮ್ ಏನು ಬಂದರೆ ಬೇಟಾ ಸೆಕೆಂಡರಿ ಚೇಂಬರ್ gas digestion time shall be at least 2 seconds. You have to have therefore you have to maintain a residue time of 2 seconds. And always, please kindly remember this, the values, otherwise it is difficult for you. Here, the combustion efficiency you have to achieve 99%, and this is estimated based on the percentage of the CO2 levels, the emission that is emitted through stacks. And primary chamber, always you have to have a temperature of 800 degrees centigrade. Secondary chamber, you have to have a temperature of 1050 plus or minus. These figures kindly remember. Secondary chamber residence time should be at least 2 seconds. And here the emission standards have to comply by the incinerator process or particle meter 50, oxygen of nitrogen 400. The hydrochloric acid should be less than 50, and total dioxin furans 0.1 nanogram toxic equivalent per nanometer. Please kindly remember these values. And mercury in this compound should be less than 0.05. Therefore, these standards, temperature, efficiency, residence time, and emission, the particle, these standards prescribed for the incident process has to be remembered by you for the exam purpose. Always stackage shall be at least 35 meters, so that through this the gases has to be discharged. Secondly, and we have got different types of emissions are there. In case of the India, we have prescribed dioxin fuels emissions should not be there, not be greater than 0.1 nanometer, the toxic equivalent per nanogram toxic equivalent per nanometer cube. And what I want to say is that small scale incinerators are not permitted, and because they will not be having single chamber incinerators also not permitted in the country, and they will not be, they may be provided the burner, but they will not be having any air pollution control systems. Therefore, this is not permitted. Double chamber incinerator without APCD is also not permitted in the country. Only the controlled pyrolytic incinerator, that means where the double chamber provided with the proper air pollution control systems and a stack of height of 30 meters, only permitted by these rules. Otherwise, these standards will not, all these standards they have to be complied by the incinerator process. Otherwise, it is the action will be taken against such type of industries. There are, coming to the non-burn technologies concerned, we have already discussed about non-burn technology, because when you discuss about autoclave, they are all non-burn technologies. Pollution due to burn technologies, there is a high pollution will be there because of incineration process, and these are the factors which affect the pollution process. And there are non-burn technology, I told you, thermal processes, chemical process, radiation process, biological process. In thermal process, there are two types of methods. One is low heat thermal process and medium heat thermal process are there. This thermal heat process is nothing but wet system and dry systems. In case of wet system, steam is the mode of treatment, whereas in dry heat system, dry heat air is the mode of treatment of waste. That is only the difference between the wet system and the dry system. All autoclave will come under the autoclave, hydroclave, and the will fall in the purview of the wet system. Dry heat system, in case of dry system, dry heat sterilization will fall in the purview of the dry heat process. This we have already discussed. I don't want to exactly tell about this, because we have already, in the last class, we have discussed about autoclave, and we also discussed about the microwave. What the temperature to be maintained in autoclave 121, pressure 15 psi. In case of gravity autoclave, we have to maintain a residence time not less than 60 minutes. Whereas in case of the vacuum autoclave, it will maintain temperature of 121, the pressure of 15 psi, and the residence time should not be less than 45 minutes. And we have to conduct the routine test, that is strip test for every batch, whereas store test has to be conducted once in a week. This is all discussed in the last week, and we also discussed about the microwave. What should the microwave, where the heat of the treatment of waste, mode of treatment of waste is using the microwave, and every system as a microwave cannot be used for treatment of all sort of waste, including the waste like cytotoxic, hazardous, radioactive waste cannot be treated by microwave, whereas the dry sterilization can be adopted by temperature maintaining 185 to 190 degrees centigrade, duration not less than 90 minutes, and you have to adopt the efficacy may be achieved by adopting the temperature and pressure of temperature as well as the duration of residence time of 90 minutes. Then you can achieve log 6 efficacy definitely, and this routine test has to be conducted for every batch, and the strip test has to be conducted for every batch, whereas the biological test, integrated test has to be conducted for every once in a week. If you adopt dry heat sterilization, but dry heat sterilization method can be used only for the purpose of treatment of the waste like shop waste, not by all. Incineration can be used for treatment of highly inflammable waste, whereas dry heat systems like the wet systems like autoclave or microwave or the hydroclave can be used for treatment of the plastic waste, under waste like the waste shops and the body implants. Whereas glass waste generally can be treated by the chemical disinfection. There is also a wet system where we use 1 to 2% of the sodium hypochlorite solution, and therefore we can achieve desired efficacy. And about the efficacy, what the difference between sterilization and disinfection is? Sterilization is nothing but the complete dissection of all forms of waste. In practice, we use autoclave or microwave or hydroclave, and using this we can achieve the efficacy about 99.9999%. Whereas disinfection is nothing but this is the reduction of microbial contamination, especially the diminution of disease-causing microorganisms or pathogens, and this process is less effective than sterilization. Therefore, the efficacy of disinfection is only about 99.99, whereas the efficacy of sterilization is 99.99. Therefore, sterilization is the reliable process one can adopt for treatment of waste. Therefore, the sterilization in autoclave is the reliable method compared with the chemical disinfection. Therefore, we can adopt the system definitely. Therefore, with this, I conclude this the chapter on my talk on the burning and non-burning technologies. And after we'll have a break of 10 minutes, and after a break of 10 minutes, and we'll start the other chapter that is on the I will take up other the topic as assigned by me on the liquid waste management by the hospital space. We'll have a break of 10 minutes. Is it agreeable? Is it acceptable to all or no?
Okay,
Can you have
sir.
a break
So,
of 10 minutes and we'll have tea and come back? Please join by 5:10, please. Today we'll have a look at some questionnaire also, please. Okay. If you complete my topic quickly, and we'll try to have a look at some questionnaire so that we'll repeat all the words that we have learned during the class, please. We'll join, please kindly join by 5:10. What is the time now?
5-9, sir.
5:09, no? Then we'll come back by 5:15, please. Okay. You all will come back by
Okay, sir.
5:15, please. Thank you all.
Okay.
Good evening. Am I audible to you?
Yes, sir.
Yeah, I think so. I don't know. Earlier, 5, 6 students were there. Now all of them are gone. I don't know whether they will join or not. But let me they continue my class. Otherwise, it becomes late. There are about 60 slides. At least I require 1 minute to explain. Otherwise it becomes late. Yeah. Can you see my slide, please?
No, sir.
Yeah. Okay. Somebody, please kindly switch off your microphone. Meera Shanish ji.
Sorry,
Can you
sir.
see my slide, please?
Yes, sir, we can see now.
You can see my slide, please. Therefore, we will not wait for much time. I will try to complete it within the time of 6 o'clock. Otherwise, it gets late. And other questionnaire, if not possible today, I will try to do it tomorrow. Definitely, I'll spend about 15 minutes to 20 minutes on the questionnaire so that, we'll have overview of all the topics, whatever I covered. I'm not going to explain in detail. This is also a science, how to treat the wastewater. You all know these are the various activities where the diagnosis and the treatment of patient in the process of diagnosis, treatment of patients and all, you are going to generate the liquid waste from all the wastewater. They were maintaining the housekeeping and all. You are going to generate liquid waste from the hospitals. In the process of treatment of waste using autoclave, you are going to generate some sort of wastewater. Therefore, liquid waste generated from the hospital requires treatment. Now, what is the consumption of the water requirement as per National Building Code? NBC of India, each and every hospital, number of beds not exceeding 100, they require about 340 liters per day. Please kindly remember these figures. Kindly remember these figures. When I say something, remember means you have to note down that one. That becomes a part of definitely exam. If number of beds exceeding 100 beds, then they require about 440 liters per day of water. This is only for the management of hospital. Therefore, per bed basis, if number of beds are less than 100, they require about 340 liters per day, whereas number of beds are more than 100. In such a case, they require about 450 liters per day of water consumption. Similarly, the nursing homes, medical quarters, and hostels per head requirement is about 135 liters. If there is a hostel, they require per head of the people staying in the hostel, they require about 135 liters per head. If there is a part of the hospitals, if they are having, we also can expect some visitors. Therefore, for visitors also, we have to keep some water consumption about 50 liters per person per day. Therefore, while estimating water requirement of hospital, as per the National Building Code, number of depending upon the number of beds and number of visitors and the staff available in the nursing homes, you have to estimate the water requirement accordingly. You have to ensure that adequate water supply is ensured. Apart from this, there should be a water supply. The water demand should be estimated for the purpose of firefighting, because of if any firefighting occurs, you should be able to take action safely, so that there will not be any problem for the hospital, not going to cause any impact on the hospital. Therefore, this hospital also will have the impact will not be there. Therefore, adequate water requirement has to be estimated at the time of planning for a hospital, considering this National Building Code of India 2005. Therefore, water requirement has to be estimated based on the number of beds and also the quarters availability and also visitors to the hospitals to look after the patients, and the firefighting also has to be taken into account. You have to estimate the water requirement. Now, these are the wastewater commonly generated from the hospitals, like which includes the various source of wastewater, which includes administration and ward. They are the source of water generation from wastewater generation from the hospitals. Operating theaters, ICUs, laboratories, radiology department, the hemodialysis, dental departments, kitchen, laundry and toilets, engineering and maintenance department. Apart from this, because of the rainfall within the hospital, you are going to generate the various wastewater runoff from paved service also. Apart from that, there will be domestic sewage. They are going to generate, which may contain cultures, stocks, and the associated biological waste, waters, body fluids, and used disinfectants, floor washings, including patient areas, hand washings, air pollution control equipment if you are operating any APC, the boilers, discharge of accidental spillage, including chemicals, laboratory effluent charges, apart from fire accidents. Therefore, these are the possible sources of wastewater generation from the hospital. This in a systematic way, just to understand easily, these are the source of the wastewater generation from the hospitals, which includes intensive care units, dental departments, ICU, radiology, hemodialysis, laundries, kitchen, administrative office, engineering department, laboratories, bathrooms, urinals, runoff from paved areas, that is a runoff, and patient wards, surgical units or operation theaters. These are the possible sources of wastewater generated from the hospitals. Wastewater generated from the hospital may be categorized into 3 types. Please kindly remember this, you can expect as a part of the question. Black water, it is nothing but a sewage. The gray water is nothing but, it is called sullage, especially from the low polluted wastewater with the residues from washings, bathing, laundry, or technical processes such as cooling water, etc. And storm water, it is nothing but the runoff water is called as storm water. And these sort of the 3 categories of wastewater can be categorized. And these are the types of contaminants that you can expect from the liquid waste generated from the hospitals. Like the important chemicals in hospital wastewater includes anesthetics, disinfectants, formaldehyde, glutaraldehyde, chemicals from laboratory activities, photochemical solutions, and X-ray the contrast media containing obsolete organohalogen compounds, mercury from dental amalgams or lab chemicals, excessive nutrients and nutrients, pharmaceuticals including antibiotics, radioactive waste from radiological departments, infectious agents including bacteria, viruses, and parasites. Therefore, these are the possible contaminants that may be likely to be present in the wastewater generated from the liquid wastewater. Therefore, the wastewater generated from the hospitals cannot be discharged directly. This wastewater has to be treated properly and ensure they meet the discharge norms before you discharge into the atmosphere or into the environment. Like infected waste, it may like cultures, stocks, and associated biologicals, liquid contaminated with the blood products, body fluids, liquid waste from oncology, like chemotherapeutic and pathology like formaldehyde, etc. The photographic chemicals can expect from these department, X-ray units department, mercury from broken obsolete equipment and dental clinics. Therefore, mercury now presently we're not using in thermometers now. Still, there are here sporadically some of the hospitals they're still using mercury-based instruments like thermometers or BP operators still are there. By chance, if any they are broken and the mercury waste, if it is not properly collected in accordance with the law, it may become a part of liquid waste. Therefore, this sort of waste from liquid waste generated from the hospital also has to be ensured proper treatment. Apart from this, can expect there will be solvents like includes halogenated compounds such as methylene chloride, chloroform, trichloroethylene, and refrigerants, non-halogenated compounds such as xylene, methanol, acetone, isopropanol, toluene, ethyl acetate, and acetonitrile are used as a part of hospitals for different purposes, and therefore there will be organic chemicals as well as the inorganic chemicals will be generated from the liquid wastewater. This wastewater this is what the components. Now I'm telling different ways, not equipped to explain different ways. These are the components that you can expect from the hospitals and already discussed in the above slides. Therefore, before discharge of the wastewater from hospitals, you have to ensure proper treatment because it is going to cause some environmental implications, which includes excessive nutrients causes biological degradation in the groundwater, lakes and rivers by using up oxygen. Therefore, they consume more oxygen. Therefore, eutrophication of lakes may takes place and contamination of groundwater may take place if liquid waste generated from the hospitals is not properly treated and disposed of. Pharmaceutical waste generated from the hospitals, the wastewater from pharmaceuticals, they may contain the pharmaceuticals and they act as endocrine disruptions. And antibiotics could result in antibiotic resistant pathogens will be there in the liquid waste if discharged into the environment without any treatment. Mercury and heavy metal also poisoning also may cause because of presence of heavy metals in the liquid waste generated from the hospitals. And if it is not properly disposed, it is going to cause the various waterborne diseases, outbreaks such as can expect some sort of the outbreaks in the hospital, such as the waterborne diseases. You remember this, please. You may cause hepatitis A and E, and also some sort of cholera, diarrhea, and this sort of the problem, typhoid, diarrhea problems will be there because of the waterborne diseases. As a part of even it may cause vector-borne diseases and parasites such as dengue, fever, malaria, and roundworms. It may cause this impact. Therefore, effect of liquid waste, if it is discharged improperly, that may cause impact on the it may cause waterborne diseases and also vector-borne diseases, the vector-borne diseases. Remember this disease name definitely. Therefore, hazardous of wastewater generated from healthcare facilities is hazardous due to pharmaceutical and cytotoxic waste, hazardous due to radioactive waste, hazardous due to hazardous chemical waste, discharges, hazardous due to microbial pathogens. Therefore, these are the main hazards of liquid waste generated from the hospitals, and therefore, liquid waste has to be properly treated and disposed of. And we have got, if you look into the, as per Biometric Waste Rules 1998, liquid waste was categorized in as category number 8 and category number 10, that is the chemical waste. Now these rules are not applicable. And now as per the latest, the Biometric Waste Rule 2016, rules for the specifies pre-treatment of liquid waste is a must. What type of the waste requires pre-treatment? Anybody can say, please? We have learned some type of liquid waste requires pre-treatment. What type of waste requires pre-treatment of Biometric waste? Can you please respond to my query? What type of waste requires pre-treatment? We have learned in the earlier class. Can you please
Sir,
say it?
patient liquid waste such as uska blood, vomiting, and
Yeah, yeah.
urine.
Waste like laboratory, microbiology, waste, blood samples,
Sir,
blood
blood
bags, you have
bags.
to do treatment. Then rule 4 also says that liquid chemical waste has to be neutralized. Isn't it? Liquid waste, chemical waste has to be neutralized. And rule K state that treatment is for liquid waste in accordance with the Water Act 1974. You have to complete the requirement of Water Act. You cannot discharge any waste, liquid waste into the environment without treatment. You have to complete the requirement of Water Act 1974. That means you cannot discharge into the any liquid waste directly into the environment without any treatment. And handling disposal of all the mercury waste shall be in accordance with the respective rules and regulations. Therefore, liquid mercury bearing waste has to be disposed of in accordance with the respective rules. And a footnote, the rules also says residual or discarded chemical waste has to be disinfected using, and all disinfected waste cannot be inserted by the through the incineration. Therefore, you can go for chemical liquid waste neutralization using the after resource recovery, the chemical liquid waste shall be pre-treated before mixing with other wastewater. And I also told how to neutralize the liquid waste in my last class also. And these are the standards you have to follow. If please kindly remember these limits, pH should be 6.5 to 9. All liquid waste generated from the hospital has to comply to the requirements. You cannot discharge this waste. And suspended solids, like it should be less than 100 milligram per liter. Oil grease should be less than 10 milligram per liter. BOD should be less than 30. And COD should be less than 250. See, by using some sort of settling tanks, you can achieve the norms like pH, suspended solids, and oil grease, and BOD and COD, but you cannot achieve bioassay. Liquid waste generated from hospitals cannot comply to the requirement of bioassay. Means if you take 5 liters of water and if you leave the known number of fish and allow it for 96 days, if it is so let us say you have allowed the 10 fishes into the 5 liters of wastewater collected from the hospitals. If no fish die is there, about let us say out of 10 fish, if it is only one fish is died, remaining 9 fish are alive, even after 96 hours, then it is passed through the bioassay test. Otherwise, it is not passing through the bioassay test. Therefore, this is without any treatment, the liquid waste generated from hospitals cannot complete this bioassay definitely. Therefore, the bioassay result to ensure bioassay parameter, the liquid waste has to be treated properly. All the liquid waste generated from hospital has to be completed this requirement. The standards prescribed under the rules I have already given. At any cost, where there is no hospitals are not having any the standards in such case, yet they have to complete the requirement of Schedule 6 standards prescribed under the rules. These are the standards prescribed under Schedule 6 of the EP Act. Definitely, you have to complete the requirement of EP Act. Sorry, 1 minute, please give me a call. I have to attend one official call. Therefore, without treatment, you can't ensure proper treatment. There is a must for treatment of liquid waste. This is the parameters which we have seen somewhere in Faridabad. I think when I dealt this subject somewhere very, very old data, they are having this sort of the parameters like BOD, COD, just for the essence of the liquid waste generation from hospitals. I just want to show you these are the hospitals where I have monitored at the time. This is the liquid waste characteristics which I have observed, and outlet of ETP, the mercury concentration also we have analyzed wherever they are. We observed some sort of mercury even in the emissions in few hospitals like Indraprastha hospital observed one, and if you have seen into AIMS, New Delhi, I have seen somewhere in 2011. I am telling you, it is very old data. Now, if you go and see the mercury levels in hospitals, you may not be available because nowadays the mercury is not at all used. There are various methods are there. Direct disposal, no cost is there, therefore you can discharge, no maintenance cost. Whereas the treatment of the co-treatment along with the sewage treatment, then no direct discharge to environment, but you are ensuring treatment through municipal wastewater treatment plant. Of course, this method is allowed wherever these wastewater treatment plants are there as a part of end of the pipeline treatment in any city. Or else you can have your own systems within the hospitals. Therefore, the method has got disadvantage and disadvantage. Direct discharge means not allowed. You have to ensure proper treatment. Otherwise, no cost is involved. Sewer and core treatment. Therefore, if there is any ETP is there, STP is there as a part of a city, for treatment of sewage generated from the hospital or from the city, then you can discharge into that through sewers, so that the treated water can be treated through that municipal wastewater treatment plant. But you have to have minimum treatment requirement within the hospital. On-site wastewater treatment is preferred, so that you can ensure proper treatment of the hospital. How you can ensure proper treatment? This is wastewater generated from the hospital. You have to segregate domestic sewage separately, and wastewater having the infectious liquid waste, that is the segregate, and ensure this proper treatment system. This is the treatment system you can adopt for treatment of liquid waste generated from the hospitals, and after treatment, liquid waste can be discharged into the sewers for further treatment and disposal. Whereas domestic sewage can be discharged directly into the public sewers. It is permitted, whereas the contaminated infectious wastewater has to be treated and disposed of. To come to this, the place, typical on-site treatment of wastewater, this is what you have to see. Every healthcare system should have the bar screen. The bar screen, you can ensure some sort of a bar screen where you can remove the floating matter. Then afterwards, the wastewater can be discharged into through the unit called grid chamber, where the solid, the particles can be removed. Then the liquid waste has to go to the equalization tank. Means the wastewater generation may not be uniform all over the hospital, and the wastewater generation may vary from time to time. Therefore, the quality of wastewater also will not be uniform. Therefore, in order to maintain uniform quality and uniform quantity, the equalization tank is followed, where you ensure you will have proper mixing. You will ensure the uniform quality of wastewater and the uniform quantity of liquid waste is managed. Then the wastewater can be sent to the aeration tank, where the wastewater is treated by the biological processes. Then the treated wastewater can go for clarifier. After clarifier, then the wastewater can be treated through sand filters followed by carbon filters, so that we can ensure proper treatment. And afterwards, the wastewater can be treated by chlorine. Before discharge, the wastewater can be treated by chlorine, means you can ensure there is a proper treatment of then treated water can be discharged into the environment. From aerobic, the clarifier or aeration tank, we are going to generate some sludge. The sludge is called as activated sludge. Some quantity is always recirculated to the aeration tank, so that in order to maintain proper biological activity within the aeration tank, and the excess activated sludge is removed, and whatever the waste received, the EDP sludge from clarifiers is received, is collected here. It will go to the digester, followed by thickener. Here you are going to remove the moisture. Whatever the moisture is removed, that will go to the equalization tank, and the dry portion of sludge is collected to the dredge dewatering process. After the sludge is dried up or through the filters, and the sludge is taken for disposal through landfill. Whatever the wastewater is treated, it can be recirculated for the washing purposes, or it can be discharged into the landfill. This is about the simple method of the treatment of liquid waste for the hospitals. I'm not going to explain in detail about the units, because not required to explain in detail, because you just need essence of the treatment system. Here, I will show the example. This is the tank where the minimum the two-chamber septic tank can also be used as a aerobic process for treatment of liquid waste generated from the hospitals. Here, it is like a septic tank where the wastewater is collected, and in the process of absence of oxygen, the aerobic process, the wastewater, the outlet is clarified outlet is collected and discharged through the soak pit. This is one method of adopting the treatment of wastewater where there is no ETP at all, or sewage treatment plant is not available. In such a case, you can adopt this sort of system. And where, in case of non-bedded hospitals, you have to ensure proper treatment of liquid waste. Therefore, in such a case, this sort of non-bedded hospitals can be adopted, like chemical disinfectant treatment methods. You are allowed to discharge wastewater by adopting chemical treatment systems. Therefore, this is a method one can follow. Anybody can explain about this, please? What is the system here? Can you understand? It is a self-explanatory system. It is the method can be adopted by any hospital, non-bedded hospitals. Means where water the wastewater generated is collected, where you are going to collect all the wastewater. Then you are using hypochlorite solution. It is mixed thoroughly. Retention time is maintained for 20 minutes minimum. Then the excess wastewater is discharged into the this method can be adopted by some sort of non-bedded hospitals before discharging to liquid waste into them. This is some of the methods followed in some of the hospitals in Bengaluru, NU hospitals. I don't know whether this system is the same or not, but it was the very old photograph which I got it earlier. And this sort of on-site pre-treatment system. That is an on-site treatment system. Liquid waste is collected here and hypochlorite solution added depending upon the flow of waste are collected. After mixing thoroughly, then it is discharged into the drain. Therefore, we have got various treatment systems. You can adopt to STP or you can have your own on-site treatment of wastewater by the healthcare facilities by adopting these tanks, these systems like equalization, chemical dosing, followed by flash mixing, slow mixing, and we will have the primary settling tank, followed by secondary treatment system where biological treatment system is adopted. Then we will have the secondary, after ASB, the biological treatment, we will have a secondary settlement, the settling tank. The water the sludge is collected from primary settling tanks and secondary tanks. Overflow will be taken to the activated filtration process. After filtration, the wastewater is collected and discharged into the drains. Just for understanding, this is the system we adopt as a primary system, bar screen, where the floating materials will be collected. This is bar screen, where the water is made to flow through this, and all the floating materials are collected, and the wastewater coming through bar screen is collected here. Then it can be the sent through other system called the grid chamber, equalization tank. Here, in order to maintain the humidity, the what do you call homogeneous nature of the wastewater, all the wastewater generation may not be at the same time, may not be uniform throughout the day. It may vary from time to time. Therefore, in order to maintain uniform nature of the wastewater quality, this equalization tank is used where the wastewater is collected from different units. Once it reaches certain level, then the wastewater will be pumped. It will go for next. It will go for next treatment unit process. Let us see what is the process here. Then it will go chemical dosage where the flash mixing here, the chemicals are applied like in order to maintain the flocculation process is proper in case of when it goes to the settling chamber. Here, the flocculants are generally added here. The detention time is minimum of 30 to 60 seconds. Here, the chemicals are dosed like ferric chloride and lime or the caustic soda is added here. The flash mixing is mixed fastly. Then it will go for slow mixing in the process. The flocks are all the solids which are in suspended form in the locked waste will come closer and closer. Thereby, the specific gravity of the particles will increase. Then they will try to settle on their own by means of gravity. Therefore, after flash mixing with the chemicals, it will go to the slow mixing tanks where flocks are formed. The flocks formation is such a way that they will have such a specific gravity, they will settle on their own by means of gravity itself. Therefore, these are the tanks where the flocks formation is taking place because of the flash mixing. It will go to the tank where the settling tanks where the waste will fall on its own by means of gravity. Here also in the aerobiotic process here, the activated sludge is the air is diffuse air is applied, and whatever the flocks are there within the floating form, they all will settle, will come into the oxygen process. The size will grow, and when it goes to the settling tanks, clarifier, we call it as clarifier. When the wastewater is sent to these clarifiers, here slow mixing takes place. All the wastewater, they will come closer and closer. Thereby, the specific gravity of the particles will be increases such a way that they settle on their own by means of gravity. They settle at the bottom, and the supernet will go to the next unit where the sludge is collected from the bottom. Here, the sludge is collected, some sludge is recirculated, and other sludge is sent to the digester. And next process will go for the biological process here. Generally, aeration is adopted. Then, after aeration and all, the wastewater is actually the system should be like this. Therefore, aeration tank, then settling tank will be there. Here, this is the process of settling tank. Then you can see that then we will go for the settling tanks where the wastewater will come and settle on its own because of this specific rate. There is the alternate momentum from up to down, down to up will be there, so that in the process, when the water is moving in the upward direction, by means of gravity, particles will come down here, supernet will go like this. Therefore, by the time this water will come here, the all solids will be settled, then that will collect from the bottom. This is the phenomenon. We just try to understand how this is operated. And this is the secondary treatment where biological treatment process is after where diffuse air is generally the scent because of because of availability of adequate the oxygen levels, and because of availability of nutrients are ensured in the secondary treatment tank, because of the biological activity, the whatever the microbes are there, they will they convert all the organic matter into they sell the after certain time they die, and that will become as a solids. Therefore, here these the solids are settled in the secondary tank, and thereby the water is removed. Therefore, here this is how the filtration we use pressure sand filters and followed by carbon filters. After treatment from biological process, the wastewater treated from biological activity will be sent to the settling tanks. After settling tanks, the supernatant water from settling tanks will go to the filtration units, where use two types of filtration units. One is pressure sand filters and the actual carbon filter. Here, whatever the leftover any microbes or any contaminants are there, that will be removed. And when it goes to the actual carbon filter, all the dissolved any gases which are there, any dissolved form or any other pollutants are there, that will be removed. Therefore, this is the example to show how the pressure sand filters are output, and you'll have different types of coarse grains from bottom to top, the fine grains. When the water passes through this, all the whatever the contaminants are there, that will remove the pressure sand filters. After that, they will go for the active carbon filter. Any the contaminants which are there, like the BOD, COD, turbidity, metals, all will be absorbed in these things. The active carbon is nothing but charcoal. Activated charcoal is there. Here it will have spores. All the contaminants will be retained here, and after this passing through this, the water will be free from all the contaminants. Then it will go for this what the treatment process. Just to understand once again, to repeat it, bar screen, go to the aeration tank. All the solids will be sent to the clarifier, and some solids will go to the settling tanks also. Afterwards, will go to the secondary the clarifier, and after accelerated process, secondary clarifier, and some the after treatment of secondary clarifier, the wastewater will go to the sand filtration powered by active carbon filter. After treatment, you can treat using, you can discharge directly, or for recirculation, sludge is collected from all the ETPs and it is removed. So liquids are removed, then sludge can be disposed through landfill, but the treated water can be discharged into the landfill directly. This is about the landfills. Just to know, just I have given you different diagrams, you can understand easily. This is some of the treatment plant adopted by the hospitals in the some of the hospitals in HL in Karnataka, in Bengaluru. This is in Haryana. Any hospital, some of the hospitals say that there no any space for them. These are the hospitals adopted in Haryana. The system they adopted, where all the treatment plant will be fabricated treatment plant, where they have to have only the collection tank. From here, all the treatment system will take place. Here, the settling tank followed by this chemical dosage. Here, the mixing will take place, followed by chemical the settling tanks, followed by filter units. Then treated water is discharged into these things. Therefore, you can have the ETPs above the hospitals also. It does not mean that you have got the problem. This is one of the college in the Saint John Medical College, where they have adopted a full-fledged the biological system, and the wastewater is treated and discharged off. And the HAL hospital, they are having this wastewater treatment system for treatment of liquid waste. There is a capacity about this is somewhere observed in 2009, very most slide, but still they are adopting this type of systems. Just to give the final, just to have your own understanding, I showed you this sort of things. Some examples I showed you, so that all the bedded hospitals, they have to have their own treatment systems. Definitely they have to treat the wastewater. It is a must for them. Whereas all the non-bedded hospitals, they have to have their at least they have to have a chemical disinfection system, so that before discharge of any wastewater, they have to treat that they can discharge for further treatment. But all bedded hospitals, they have to have their own treatment system to ensure proper treatment and to comply to the requirement of liquid waste discharge standards as different the rules. Then only the hospital is complying the requirements. Otherwise, the hospital is not allowed to discharge any wastewater without proper treatment. This is about liquid waste management in the hospitals. I also already time is lacking. I also questionnaire we'll see tomorrow. I'll try to complete. But tomorrow topics are very more topics. I can cover up within half an hour, and later on remaining half an hour, I will try to. What I do is tomorrow. What I can do is tomorrow definitely I can share the questionnaire so that we can have a discussions about this. Try to understand tomorrow class. That's very short. The class I can take One is on the what are the regulations followed in share countries, and also what are the international the conventions where we are a part of various conventions that I had explained. I will try to complete it within 1 hour. Remaining 1 hour, I'll take up questionnaires and we'll have a look at all the questionnaires, whatever the topics are covered. That things we'll try to cover up both. And if you have any questions, you can ask now, please. Relating to burned and non-burned technologies and the liquid waste management, you can have a discussion, please. Yes, please.
Thank you, sir.
Okay. Any questions, please? Otherwise, we will conclude this session here, please. Tomorrow, please kindly make it convenient to yourself to attend my class tomorrow. I'll try to spend about 1 hour 15 minutes towards my 2 lessons. Remaining 45 minutes, we will have a look at some various questions covering all my topics, please. If no question, then you can conclude, please. Thank you all for attending this class. Still, if you have any questions, you can communicate to me on my email ID, which I have given, or I will try to share. If you want my presentations, you have to request me through email. I will try to share my presentation also. Thank you all once again. Thank you for attending the class. Thank you very much.